Welcome to our channel. In this video, we are going to discuss about Reimer-Tiemann reaction. In our channel, we are providing handwritten notes for every topic that we have explained and which is in very easy format and also better to understand. If any one of you need to download handwritten notes in a PDF format for this topic, you just go and check out the description or else comment section where I have given link to download PDF of this topic notes. Now, let's move on to the topic. Reimer-Tiemann reaction, which is very important chemical property of phenol. In this reaction, phenols react with chloroform in the presence of sodium hydroxide at 70 degrees centigrade temperature. It is forming orthohydroxybenzaldehyde and parahydroxybenzaldehyde. So here orthohydroxybenzaldehyde is a major product and parahydroxybenzaldehyde is a minor product. So here we can see that CHO group is introduced on the ring because the action of chloroform and sodium hydroxide. Okay. So let us see the mechanism of this reaction. So at the beginning I am taking NaOH and NaOH is breakdown into Na plus and OH minus. So now you can see the chloroform, that is carbon and 3 chlorines, 1 hydrogen. So this is actually chloroform, just I am writing like this. So here I am shifting the bond of this carbon and hydrogen towards the carbon. So what will happen? This carbon gets negative charge and hydrogen gets positive charge. Now this OH minus attracts the positively charged hydrogen and forming the water molecule. Now this CCl3 minus is forming as an intermediate here. Now I will remove one more chlorine ion in order to satisfy this negative charge. So I will remove this one chlorine ion. So if I will shift this bond, it will get chlorine minus. So chlorine minus is coming out and CCl2, that is dichlorocarbene, is forming as a intermediate here. So now I will take one phenol. From this phenol I will remove proton. If I shift the bond between this oxygen and hydrogen towards the oxygen, then oxygen gets negative charge, hydrogen gets positive charge. So hydrogen is coming out, that is H plus is coming out and oxygen is getting a negative charge. So this is called phenoxide. So after removal of proton from the phenol, that is called as phenoxide. Now what will I do? I will add the dichlorocarbene to this phenoxide. And this dichlorocarbene acts as an electrophile in this reaction. So what will happen? Again I will shift this bond towards the carbon. Then this carbon gets negative charge and this carbon gets positive charge. So this positive charge and negative charge forming a double bond here. So this carbon gets negative charge now. It attracts electrophile, that is CCl2. And even here one more hydrogen is there in this benzene. So I am representing this hydrogen like this. So here carbon is getting a negative charge because of donation of electrons. Otherwise we can say that this carbon can form one more bond. So because of that I am giving negative charge here. So now what will happen? Again I will add the proton in order to satisfy this negative charge. So if I add water molecule, the proton from the water molecule reacts with this negative charge and forming CHCl2. So we get CHCl2. So in order to satisfy this bond, I will remove the proton now. So I will shift this double bond towards oxygen. So oxygen gets negative charge and this carbon gets positive charge. So to this positive charge, proton is donating electron and forming the double bond here. Okay. So now hydrogen in the form of proton is coming out. So finally oxygen got the negative charge. Now what will I do? I will add 2 hydroxide ions to replace these 2 chlorine ions. Are you getting my point? If I add 2 hydroxide ions, these 2 chlorines are replaced with 2 OH ions. So you can clearly see this CH, OH, OH. Okay. So again from this I will remove water molecule. So I'll remove the water molecule and I will get the aldehyde group. Okay. So finally in order to get phenolic form I should add proton. If I'll add proton I will get OH. This O minus attracts this H plus and forming OH. And we are getting the benzaldehyde as a product. So this is nothing but orthohydroxybenzaldehyde. Otherwise, we can call this as a salicylaldehyde. So this is our final product in Reimer-Tiemann reaction. So in these two products, we get orthohydroxybenzaldehyde as a major product because here inductive effect plays an important role. Here basically CHO group is the electron withdrawing group. Okay, so this OH donates electrons in order to satisfy the withdrawing nature of this CHO group. So both are near to each other and satisfies their electron withdrawing capacity. Okay, so here if we observe this para position to CHO is far from OH. Okay, so even though it is donating electrons, it cannot satisfy CHO electron withdrawing capacity. So when they are near to each other, that is when these groups are near to each other, the inductive effect is more. And when these groups are far from each other, the inductive effect is very less.